Hello and welcome to the 9th video of this algorithmic trading video course. As always, I recommend starting with the first video if you're new to this course, since you otherwise might not fully understand some of the covered topics. In this video we will cover how you can add custom data to QuantConnect and use it for the decision making of your algorithms. The ability to add custom data is very powerful since it opens so many doors. You could, for instance, add social media data, weather data, SEC filings, news data, or whatever data you can find. Even though QuantConnect already offers a huge variety of different data, adding your own data gives you even more possibilities. To demonstrate this feature, I will create a trading bot that trades Tesla stock based on simple sentiment analysis of Elon Musk's tweets. But before we get into coding this trading bot, let me start by presenting the whole spectrum of options that QuantConnect provides when it comes to adding custom data. To add custom data, you can use the Datetimehelper method. You usually would do this in the initialize method of your algorithm, since you only want to do this once in the beginning. Add data takes 3 arguments. The first one is the type of data that you want to add. Usually you would have to create a custom class for this and use this class as the type. You will see a concrete example of this in a few minutes. The second argument is a string which represents the ticker for that data. And the third argument is a resolution which specifies how often the custom data should be polled. If, for instance, you specify a minutely resolution, the algorithm will check for the new data once a minute. You might be able to see that the add data method is very similar to the add equity method. In fact, they both fundamentally do the same thing. The add data method is just a little more general. Like I just said, the first argument of the add data method is the type of the data that you want to add. For this, you should create your own custom class. This class should extend the Python data class and it should override the reader and Getsource methods of that class. The Getsource method is used to get the source of that data and the reader method is used to read your custom data. Since the data is custom and not standardized, you need to specify the structure of that data in the reader method. Let me present how to implement these methods with an example of custom weather data. For this, let me start with the Getsource method, which is actually very simple to implement. All you have to do is return a subscription data source object. To create such an object, you need to pass 2 arguments to its constructor. The first is the actual source of your data, and the second one is a type of subscription transport medium. As the source, you usually would specify a URL, such as a Dropbox URL, where you uploaded your custom data as a CSV file. For the subscription transport medium, you have 4 options. Probably the most common one is remote file, which means that the algorithm expects one file with all the data in a remote location, such as your Dropbox. Alternatively, you could also use local file if the data is accessible locally. Besides remote and local file, there also are options REST and streaming. REST is used if each line of the custom data should be polled individually and comes from a REST call. This might be the case if you have a subscription to a data vendor that provides you with custom data in real time. For our example, we have custom weather data in a Dropbox. The URL to this data is specified as the source, and for the subscription transport medium we choose remote file. In some cases, you might want the Getsource method to return different data depending on whether you are backtesting your algorithm or actually live trading it. If, for example, you have a real-time data subscription, you can't use that for backtesting and might instead want to use a CSV file for the historical data when you are backtesting. For this, you can use the isLive flag, which is true when you're live trading and false if you're just backtesting. Now, the data specified in the CSV file will get sent to the reader method line by line. The goal of the reader method is now to standardize this data so that your algorithm understands what it looks like and it can actually use it. Before I show you how you can implement this reader method, let me first quickly show you what the data actually looks like. As you can see, this data has 11 entries divided into 4 columns. Column A specifies the data for each row. The first 4 digits specify the year, the next 2 the month, and the last 2 specify the day. Column B represents the max temperature in degrees Celsius for that day. Column B represents the daily average, and column C is the minimum temperature. I know this data does not look very interesting, and I actually don't even know what location this weather data was taken from. However, in my opinion, this example is a great and simple way to understand how to use custom data in QuantConnect. Theoretically, you could use weather data, such as this one, for trading in the agricultural space, since this is heavily weather dependent. Here, it might also be useful to take precipitation, the weather forecast, and other variables into account. That said, you now hopefully have a good understanding of how this custom weather data is structured. Remember that this data now gets fed to the reader method line by line. The first thing we want to do in the reader method is check whether a meaningful line of data was passed to it. We do this by checking if the line of data is not empty and that the first value is a digit. This ensures that we don't try to use the data from the header index and don't continue if there's no data left. So if this is not fulfilled, we just return an empty object. Otherwise, we split the line at its commas and save the generated list to the data variable. Note that we can split at commas since the file is a CSV file, which stands for comma-separated values. Then we create an object of the weather class. Since this class extends the Python data class, there are three important properties that we should set, namely the symbol, value, and time property. For the symbol property, we should always use config.symbol. For the time, we need to correctly format the values from the time column in the CSV file. We can do so with this Datetimehelper method, in which you can specify the format of the date and time. Here, it is very important to understand that data in QuantConnect is passed on at its end time, and usually the data and time in a custom file is the start time. That's why it's essential to add a time delta to the start time. If you don't do this, your algorithm might access this data before it actually would be known. This is called look-ahead bias, and it can lead to very unrealistic results. That's why we add a time delta of 20 hours to the time of the weather data. If we would not do this, the algorithm could use the weather data for a given day at the beginning of the day before it actually would have been known. Next up, we set the value attribute of the weather object. For this, we will take the daily average temperature, which was saved into the second column of the weather data file. Note that the value attribute always is a decimal object. Besides that, we also create two more properties for the max and min temperature that were saved in the first and third column. Last but not least, we return this weather object. Since custom data can sometimes lead to some unexpected errors, it usually is a good idea to add some exception handling to the reader method. I will show you a simple example of this when we get to the coding part of this video. You can now access this custom weather data like you would access other price data. Inside of the onData method, you can index the data slice object with the symbol of the custom data and then access values either with the getPropertyHelper or the .value attribute. Note that if this still seems a little overwhelming to you, don't worry too much. We will go over another example step by step when we implement the Twitter trading bot in a few minutes. Besides adding custom data that you want to access on the go line by line, QuantConnect also allows you to add static data. If, for instance, you just want to add a file containing a list of tradable symbols for your universe or an AI training model file, you can accomplish this with the self.download. As an argument, you can, for example, once again just pass a Dropbox download URL. If the file is a CSV file, you can then use pandas to convert this file to a pandas data frame. Note that if you want to use custom data from a data vendor such as Quandl, Tingo or Intrinio, QuantConnect does offer direct helper methods for this. Here, you only have to provide your API token and you're good to go. For the specifics on how to do this, I recommend checking out the documentation page. That said, let me now move on to the Elon Musk Twitter Tesla trading bot that we will code in this video. As always, I will first give a rough outline as to how this strategy works on a conceptual level before starting to actually code it. The idea behind this bot is that we will use the tweets from Elon Musk to perform sentiment analysis, and based on the results of this analysis, we will then make a trade decision for Tesla stock. For this, we will only consider those tweets that mention Tesla in some way. For these tweets, we then use a sentiment analyzer to find out whether this tweet has a positive or negative connotation to it. If it is positive, we establish a long Tesla position for that day. If it's negative, we short Tesla for that day. If it is mostly neutral or slightly positive or slightly negative, we don't do anything. For the sentiment analysis, we will be using Python's Natural Language Toolkit NLTK package. Note that if you aren't familiar with this module, don't worry. We will just be using a pre-trained sentiment intensity analyzer. But if you're familiar with it, you could try using your own custom models for better analysis. Since QuantConnect does not directly offer tweets as data, we will have to find a dataset containing Elon Musk's tweets and then import this custom dataset so that we can use it for backtesting this strategy. Luckily, I found a dataset containing Elon Musk's tweet from 2012 until 2017 for free on Kaggle.com. This means we can use this dataset to backtest this strategy at least from 2012 until 2017. However, before we actually import this dataset, I firstly want to perform some pre-processing on it, since we otherwise might run into some unwanted problems. For the pre-processing, I will import this dataset into a Jupyter notebook where I will use pandas to import it into a data frame. Note that if you want to code along when I code this trading bot, you won't have to do these steps since you can access the pre-processed file through the link in the description box below. The unprocessed dataset contains 5 columns, including values such as retweets, the row number, and account. But we are actually only interested in 2 of these columns, namely the tweet itself and its date and time. So firstly, we want to remove the 3 unwanted columns. Next up, I want to change the order since we want the most recent tweets to be at the bottom and the least recent ones at the top. Besides that, we will remove all URLs from the tweets since they can lead to some unexpected formatting problems and they don't really add any value to our sentiment analysis. After that, I exported the pre-processed data to a new CSV file and uploaded it to Dropbox. Through this Dropbox URL, you can now import the tweet data into QuantConnect, where we will use it to test our strategy. If you have not yet created your free QuantConnect account, you can do so using the link in the description box below. In QuantConnect, we will head over to the Lab tab where we'll create a new algorithm. As always so far, we won't be using the Strategy Builder tool. Instead, we start with a blank template containing only the initialize and onData methods. The first thing we do in the initialize method is set the backtesting timeframe to the time covered by the Musk tweets dataset. So we set the start time to November 2012 and the end time to the beginning of 2017. The starting balance I will just leave at $100,000. Before we move on, let me import Sentiment Intensity Analyzer from NLTK Sentiment. We will use this sentiment analyzer later to analyze the sentiment of the tweets, but more on that later. Thereafter, we want to add the data that this algorithm will use. Firstly, we add Tesla data, which we can do with the usual Datetimehelper method. Since the tweets can be sent pretty much at any time of the day and we have specific timestamps for them, we'll set the resolution for the Tesla data to minutely data. Then we want to add our custom data. We can do so with the addData method, which takes 3 arguments. The first is the type that this data will have. I will pass Musk tweet for this, which is a class that we will implement in a few seconds. As the second argument, you need to specify a ticker symbol that you can use to access this data with. For this, you can choose whatever name you want to. Just try to pick one that isn't already occupied by some stock or other asset. I will just go with Musk tweets. Last but not least, you need to specify a resolution. This resolution will determine how often your algorithm polls your custom data source for potential new data. Here I will also go with minutely data. Since the tweet data actually has timestamps with up to second accuracy, we could also go with secondly data, but this would slow backtesting down and in my opinion isn't that important for now. Note that just like for equities and other assets, we can use .symbol to save the symbol for this data to a variable. We will do this so that we can later use this symbol to request the data. For this, you could also use the specified ticker, but that can come with unwanted ambiguity problems. For details on this, go watch the third video of this series. Next up, let's start implementing the Musk tweet custom data class. Like I mentioned in the theory part of this video, this class has to extend the Python data class and it has to implement the getSource and reader methods. Let's start with the getSource method, but before we do so, make sure to note that this class no longer is part of the QC algorithm class, so you won't be able to access the usual helper methods such as self.debug in here. Before we move on, let me save an instance of the NLTK sentiment intensity analyzer into a class variable named self.sia. In the reader method, we will use this for the sentiment analysis. That said, let's implement the getSource method now. Here, we simply want to set a Dropbox URL as the data source. Note that here it is very important to have DL equals 1 at the end of the URL. DL stands for download, and we want the algorithm to download this data. If you would want to view the CSV file online, you could do so by setting DL equal to 0 and opening the URL in your browser. However, for the algorithm, you will always have to set DL to 1 when using Dropbox URLs. Then, all we have to do is return a subscription data source object. For this object, we will just use the saved URL as the source and specify this to be a remote file. If you would want to live trade such a bot, you would have to connect this bot with some kind of Twitter API that sends you real-time tweet updates. In that case, you would use the REST or streaming subscription transport medium option. To differentiate between backtesting and live trading mode, you could then use the isLive parameter of this method. But since we will just use this for backtesting, we won't have to worry about this for now. Next up, let's move on to implementing the reader method, which handles bringing the data into the right format so that your algorithm can actually use it in a meaningful way. Remember, the reader method receives data from your remote file on a line-by-line basis. So the first thing we need to check in here is whether the line actually contains relevant data. If, for instance, we receive an empty line or the first index row, we won't do anything, which is why we return none. Otherwise, we split the line by commas, since the data comes from a comma-separated file. The data variable now is a list containing two elements. The first element is the date and time of the tweet, and the second element is the tweet content itself. Next, we create an instance of the Musk tweet class and save it to a new variable named tweet. The next step is to set the symbol, time and value of this Musk tweet object. For the symbol, we can just use config.symbol. Config is one of the parameters of the reader method. As for the time, we have to specify the format of the time column in our custom data. The format is year, month and day separated by a dash, and hour, minute and second separated by a colon. Note that we add a time delta of 1 minute to this time, since this will be the end time of this data point. Since tweets should be available pretty much right away, we could also use a time delta of 1 second, but since we're using minutely data anyways, this likely won't make a big difference. Be aware that when using price data or other data covering a certain period, to always correctly adjust the time to the end time of the data. Otherwise, the results can be very unrealistic. After setting the time, we convert the tweet, which is saved into the second place of the data list, to lowercase and save it to the content variable. Now, we want to perform some simple sentiment analysis on the content of each tweet. However, we are only interested in those tweets that reference Tesla. Since the tweet was converted to lowercase, we can check whether it contains the ticker symbol of Tesla or the written out version. If it does, we use our sentiment intensity analyzer to calculate a polarity score for the tweet. This polarity score will return a dictionary with scores for negative, neutral, positive, and compounded sentiment. This tweet says that Tesla just had its first profitable quarter thanks to awesome customers and hard work by a super dedicated team. If we would use the Polarity Scores method on this tweet, it will return the following dictionary. As you can see, according to the sentiment intensity analyzer, this is a mostly positive tweet, which does make sense. Note that the compounded sentiment is not just an average of the others. An example of a tweet with a negative sentiment would be this one. Not all good news, Virginia DMV Commissioner just denies Tesla a dealer license. This is interpreted to be a neutral to negative statement. But note that often the sentiment analysis isn't as accurate as in these two cases. What we want to do is use the sentiment to either establish a long or short Tesla position. We will only use the compounded score for this though. That's why we save it as the value of the tweet data object. In the case that Tesla was not referenced in the tweet, we just assign it a score of 0, which would be equivalent to a completely neutral tweet. Next up, I also want the content of the tweet to be accessible in the data bar. To accomplish this, we can simply create a property for the tweet object with whatever name you want to and save the content to it. We will use tweet as the name for this property. Earlier in the video, I mentioned that sometimes there can occur some unexpected problems inside of the reader method since we are dealing with custom data. That's why it makes sense to add some form of exception handling here. So let's put a try statement around this code, and if a value error is thrown, we simply return none. After that, all that's left to do is return the tweet object, and then we are done with the reader method. Now we're almost done. We just have to quickly implement the onData method and the exit logic. The first thing we do in onData is check whether the data slice object contains any data for the Musk tweets. We check this with the symbol object of that data. If that's the case, we can save the score of the current tweet with data.value. To access the content of the tweet, we can use .tweet, which is the name that we gave this property in the reader method of the Musk tweet class. For this algorithm, we will establish a long position if the compounded sentiment score is above 0.5 and we establish a short position if the score is below negative 0.5. We can check this with a simple if-elif condition and use set holdings to go long or short. For demonstration purposes, I will also log the score and content of the tweets that meet one of these thresholds. Now all that's left to do is add a method that liquidates any open position before the market closes, since we don't want to hold Tesla overnight based on one tweet. For this, we can schedule an exit positions method in the initialize method. We schedule it to be called 15 minutes before the close on every day that Tesla trades. In the exit positions method, we then simply have to call self.liquidate to close all open positions. With that, we are now done implementing this Twitter sentiment analysis trading bot. So let's now build and backtest it. As you can see, this strategy seemed to perform quite okay over this time frame. However, here it is important to note that it isn't a very long time frame and Tesla had a huge bull run over the past few years. If we scroll down to the stats overview, we can see that this bot made 165 trades over this time frame, which is a solid amount. If we go to the logs tab, we can see an overview of the scores and content of those tweets that the algorithm used to actually base trades on. Some of them make sense, such as the tweet on the 4th of December 2012 that says that Musk is happy to report that Tesla was narrowly cash flow positive and he expects continued improvement. This had a polarity score of almost 0.9 and led to a long position. However, some of the other scores and tweets aren't as clear. If you want to look at these results in detail, you can use the link in the description box below to clone this algorithm. Note that to test this strategy over another time frame or live trade it, you would need to find a data source that gives you access to Elon Musk's tweets over the desired time frame or in real time. This data will likely be structured slightly differently than the data from this video. That means you would probably have to adjust the reader method to some extent to use that data. Also note that the sentiment analysis here is very simple and the pre-trained sentiment intensity analyzer likely isn't optimized for Twitter text data, since this data usually has a different structure than other text data. So there certainly are many areas to improve upon. That said, I hope that this video gave you a good overview of how to import custom data into QuantConnect. I also hope that it shows you why this is a very powerful feature, since it gives you so many more options as to what you can do. For some other examples of algorithms that use custom data, check out the algos referenced in the documentation page. With that being said, if you're enjoying this series, make sure to smash the like button, subscribe, and turn on the notification bell. Thanks for watching.